Good morning or afternoon. I guess depends when you're listening to this video. We're going to learn about some triple Venn diagrams right now. So it's pretty much the same concept as double Venn diagrams, which is the lesson before this. We're just going to add another circle to it. We're going to start off by reading a question and then just interpreting a triple Venn diagram. So let's get at it. Example 1. In this diagram below, let P represent the number of people who have pigs, C represent the number of people who have cats, and D represent the number of people who have dogs. Just a reminder, when we look at these things, right? P represent have pigs. That means anyone in this circle that I'm circling in red right now, that's the P circle. Those people have pigs. C is people who have cats. Let's see who have cats. That means this blue circle, if you're inside that circle, you have a cat. And last one, the D, who have dogs. This green circle over here, anyone inside that circle owns a dog. Right? Now the numbers differentiate groups. Some people have pigs and dogs, right? Some people have pigs and dogs and cats. So that's why you see numbers all over the place. It's also why you see overlaps around those circles. First question, how many people only have pigs? Only have pigs. Only is a keyword here. That means that they have pigs, but they are not in any of the other circles. So if we were to look over here at our Venn diagram, these three people are in the pig circle, but not in any of the other circles, meaning that they only have pigs and nothing else. The other numbers in the pig circle have another type of animal. These 13 also have cats. These 12 have cats and dogs. These 14 have dogs. So when we're looking for only pigs, we're talking about those three people. And that only is a key word. If you look at question 2, it says how many people have pigs. They've gotten rid of that word only. Now I'm looking at all the people that are inside that red circle. These 13 people have pigs. They're in the red circle. These 12 people have pigs. They're in the red circle. And these 14 people have pigs. They're in the red circle. So when I say how many people have pigs, I need to add all the numbers that fall within the pig circle. So if you take out your calculator and you add that in there, you're going to go 3 plus 13 plus 12 plus 14 for a total of 42 people who own pigs. I wish I had a pig. The little potbelly pigs are adorable. Perfect. Number 3. How many people have cats and dogs? Okay. And is key, right? It means you must have both. So when we look at this circle, we're looking for people that are in both the cats and the dogs circle. For instance, this number 9 is in the cat circle in blue, and it's in the green circle for dogs. So those 9 people have both cats and dogs. A lot of the time, 9 is the answer I would get here, which is partially correct, but it's actually missing a group of people. Because these 12 people right in the center, if I asked you, do these 12 people own cats and dogs? The answer would be yes. The difference between those 12 and the 9 below is that those 12 have pigs as well. This question never asked anything about pigs. It just asked, do you have cats and dogs? Do you have both? Those 12 people do have cats and dogs. So you would have to add them to the other 9 people that also have cats and dogs, for a total of 21 people that have cats and dogs. Wonderful. Next one. How many people have pigs or cats? Or is inclusive. So that means anyone who has a pig or anyone who has a cat would be included in this number. I like to always say it's like adding 2 groups together. So if I look over my Venn diagram, These 3 people have pigs, so they would count. These 14 people have pigs, so they would count. These 12 people have pigs and cats, but they still count. They just happen to have both. These 13 people have pigs and cats. They just happen to have both, but we still count them. These 6 people out here have cats. They don't have pigs, but that's fine because the question was or. It's okay if you don't have a pig. You just have to have a cat or a pig or both. And lastly, these 9 people over here, they have a cat, so we would include them. Notice that I even included those people who have like dogs, right? The question has nothing about dogs. So I basically ignore the green circle altogether, and I'm just underlining and including anybody that's in the pig or cat circle, because the question never even mentioned dogs. If we add that all up, that's 57 people who either have a pig or a cat or both. Fantastic. Number 5. What does the 2 on the outside of the circle mean? That's a great question. So if you look at our Venn diagram, we have 2 out here on the outside of the circle. When you describe a number in a Venn diagram, make sure that you refer to everything you know about those people. Be very specific. So don't say those 2 don't have any of the 3. That's not specific enough. They don't have any of the 3 what? And like, well, what don't they have? Be very specific. Those 2 people do not own a pig or a cat or a dog. They don't own any of the 3. All right, notice that I referred and I actually stated all 3 circles and all 3 animal groups there. I didn't just say it in general terms. They don't have anything. Nah, that's not good enough. Make sure you actually write what each group is. And last question, how many people have all 3 types of animal? All 3 animals. That would be these 12 people right in the center. Right? Those are the people that are in all 3. That means there's 12 people who have pigs, cats, dogs. Be a pretty crazy house. Fantastic. So you see, like a triple Venn diagram is the same thing as a double Venn diagram. We read it the exact same way. There's very little difference to it other than there's another thing and more groups, right? I'm just separating more groups. We're going to do a little bit of shading. We did some of this with double Venn diagrams. We're going to do with triple Venn diagrams. And we're going to try to build a triple Venn diagram. So actually putting numbers in, which is hard. Example number 2. Use set theory notation to represent each symbol or each set and shade the appropriate region. So looking at this first question, A and B, if you were to write that with set theory notation, it'd be A and B. Remember that and is like both, right? So you are in A and you're in B. You're in both. If I wanted to shade that region, this is the section that would be in A and in B. Notice that part of it's actually in C. That's fine because the question doesn't talk about C, right? That is the overlap between A and B. Question B, A or B. If we write that in set theory notation, that's A or B. That means you could be in circle A, or you could be in circle B, or you could be in both circle A and B. Or is like a union of sets. You're adding 2 sets together, right? You're connecting them. So if I was to shade it, I'm shading everything in A. I'm shading everything in B. Even the stuff that's in C, right? C doesn't matter at this point when I'm talking about it. I'm just shading the things that are in A or B. I'm adding those two groups together. Wonderful. We got 2 more to go here. Question C is A and not C. So if I was to write this in set theory notation, I want to be in A and is that symbol. Not C means I do an apostrophe on C. If I wanted to shade this, that means I have to shade inside of A, but I can't shade inside of C. So looking at my Venn diagram, this section is in A and not in C. I include this top section that's in B because even though it's in B, the question never mentioned B, it just said in A and not C. That blue area is in A and not in C. Sometimes people are like, yeah, but you should shade down here, Miss Kennedy, because that section's in A. And while that's true, that section's in A, it's breaking our second rule, which is not in C. Right? That section's in C. And means you have to be following both rules. D. A and not B and not C. So, if you were to write this out, you're in A and not in B, so that's an apostrophe, and not in C. So now we're a little bit more specific. We want to be in A, and we have to follow the rule not in B, and we have to follow the rule not in C. So I have to follow all 3 of those rules. To follow all 3 of those rules, I would draw out here. That section is in A and not in B and not in C. Got a little voice crack going on here. I gotta take a drink of water. Perfect. That's shading Venn diagrams. There's a good chance you get shading questions on a test or quiz. And just because they've popped up on diploma exams in the past. So we'll probably do it again. All right, down here, example 3. This is the tricky one. We're going to build a Venn diagram. We're actually going to take numbers and put them into a triple Venn diagram. Example 3. Out of 185 students surveyed. Okay, that's important. 185 students surveyed. That means the total in your Venn diagram should equal 185. The following information was gathered about students who drink root beer, Coke, and orange pop. They give us a ton of information. 25 drink all 3, 52 drink root beer and orange, 43 are Coke and orange, 57 root beer and orange, 92 drink root beer, 115 Coke, 100 drink orange. Perfect. Lots of info there. Create a Venn diagram to represent the situation. Okay, here's our Venn diagram. When we're building Venn diagrams, there's a key to it all. That key is always start in the middle. Always. Okay, that means I need to fill in this section first. Then you can work your way out. The next outer sections would be these ones. Right? Those are the next closest to the middle. Then you can do these outside ones. And lastly, we fill in any number that might go out here. Okay, so when I'm building a Venn diagram, I start at the center and I work my way out of that center. Perfect. Red, right in the middle. Let's start there. That would be you drink all 3 pops. We have root beer. I don't have letters on this. We have root beer, so let's go R. We have Coke. And we have orange. So I want to figure out the center. That would be people who drink all 3. The beauty of triple Venn diagrams is they will always tell you that number. You won't have to actually calculate it like you might have to with a double Venn diagram. And if you look at our information, look at that. 25 drink all 3. They gave you that middle number. 25 drink all 3. Then work your way out. So I have those 3 blue sections that would be next. Okay, the blue section above, that would be you drink root beer and Coke. When look at this, it says 52 people drink root beer and Coke. So the mistake people make is they put 52 right here, which is incorrect. The reason that's incorrect is because that space is not drink root beer and Coke. That space is drink root beer and Coke and not orange. The area that says drink root beer and Coke is actually this region all the way around, right? It's both of these numbers. So when I say 52 people drink root beer and Coke, I've already counted 25 of them in that very center number. So to figure out how many drink root beer and Coke but not orange, I would need to go 52, subtract the 25 that I already knew, for a total of 27 who drink root beer and Coke, but not orange. Now looking at that Venn diagram, if I added that together and I said who drinks root beer and Coke, 27 plus 25 is 52. There's 52 people who drink root beer and Coke. That is correct. We're going to do the same thing for those next 2 blue regions. So the next 2 blue regions are Coke and orange. So that region right there that I just erased. In my data, it says 43 drink Coke and orange. Right, but we already counted 25 of them in the very center. So 25 of those 43 also drink root beer. We want to figure out how many of them don't drink root beer. So I'm going to go 43. I'm going to subtract that 25 that I already counted, and that'll give me a total of 18 people who drink Coke and orange, but not root beer. That gives a grand total of 43 who drink orange and Coke. Beautiful. Last blue section. That would be root beer and orange. Looking at my data, it says 57 drink root beer and orange. Just like the other questions, I'm going to have to subtract away that 25 in the middle so that I get the right answer of 32 people who go in that spot. If you were to add 25 and 32, it does equal 57, which makes sense. That says 57 people drink root beer and orange. Both these groups do drink root beer and orange. The difference is one of them doesn't drink Coke and one of them does drink Coke. I always call it like subtracting the overlap, right? Make sure you subtract whatever overlap you already have included. And the last sections are these green sections. Let's start with this one. That would be people who drink root beer. It says 92 drink root beer. That's true, but 92 does not go there. If I put 92 there, that would be wrong because now look at my root beer circle. I have 92 plus 27 plus 25 plus 32. That's insane. I do not have that many people who drink root beer. This section is how many people only drink root beer. That means I need to do 92 and subtract all the people that are already in the root beer circle. The 27 people are in the root beer circle. Subtract the 25 people in the root beer circle. And subtract the 32 who are already in the root beer circle. And that'll tell you how many people only drink root beer, which is what that last section is about. You put it in your calculator real quick. It means that there's 8 people who only drink root beer and not the other flavors of pop. Moving on to our next section, let's look at Coke. Sorry, just had a little visitor there. So I'm on to, I got my 8 people who only drink root beer. And now I'm moving on to who drinks Coke. So only drinking Coke. It says 115 people drink Coke. That is not 115 people only drink Coke, right? And this section is only drink Coke. To figure out who only drinks Coke, you need to take 115 and subtract all the other people that are inside the Coke circle already. So subtract 27, subtract 25, subtract 18, and that will tell you how many people only drink Coca-Cola. If you put that in your calculator real fast, I have to get my note, 115 minus 27 minus 25 minus 18, for a total of 45 people who only drink Coke. And our last one would be orange. Again, it's only drink orange. So I'm going to take those 100 people who drink orange, and I'm going to subtract all of these numbers that were already inside that orange circle. So 100 minus 32 minus 25 minus 18 for a total of 25 people who only drink orange pop. If you only drink orange pop and nothing else, you're a weirdo. Orange pop's disgusting. Perfect. We filled out that Venn diagram. When you're done, though, you always want to check to see if your universal set has been completed. So remember at the very beginning, they said that there was 185 students surveyed. That means if I add all these numbers up, they should equal 185. So every number in that circle, 8 plus 27 plus 45 plus 25 plus 32 plus 18 plus 25. If you total all of that up, it should equal 185. We add it up, we get 180, which does not equal 185. So what the heck? All right. If that number doesn't match, if you have too many people in your circles, you've made a mistake. Okay, so if I had added those all up and it was like 210, I've made an error somewhere in my circles. If I've added everything in the circles and it's not a big enough number like what we have, it's because there's this outside section. There's this outside section that didn't drink any. Right? In this case, what I'm missing is 5 people. If you're not sure, you go 185 minus 180, and that'll show you the people that you missed inside of your circles of your Venn diagram. Those are the people that do not drink anything. There's 5 people who do not drink any of those 3 pops. And now, if I added the entire universal set of my Venn diagram, I would equal 185. Wonderful. Let's just do 3 quick questions. Question number 1, how many people do not like any of the drinks? We already answered that. There's 5 people who do not like any of the drinks. Question B, how many people only drink Coke? That means you're in the Coke circle but no other circle. These 45 people are inside of the Coca-Cola circle but not in the others. And how many people drink Coke or root beer? That means that you could be in circle C or in R or in both. Looking up here, that's going to be a lot. For instance, these 8 people drink root beer. These 32 drink root beer. These 25 drink root beer and Coke. These 27 drink root beer and Coke. These 45 drink Coke. These 18 drink Coke. All the people that I just put a box around drink either Coke or root beer, or in some cases, both. The question did not ask anything about drinking orange pop, so it doesn't matter if you are in orange circle or not in orange circle. As long as you are in Coke or root beer, you're good to go. So let's add those up. 8 plus 27 plus 45 plus 25 plus 32 plus 18. And that will tell you how many people drink Coke or root beer. The other mistake people make on this question is they would go back to the data, like the list bullet points up top, and they would add those numbers together. Once you've created a Venn diagram, use that Venn diagram to answer questions. Add those all up, and you should get 155. I wrote 115 there. I apologize. Fantastic. That is triple Venn diagrams. Make sure you do some practice. If you're still struggling with triple Venn diagrams, maybe go back and practice your double Venn diagrams. Otherwise, go on and start practicing your triple Venn diagram questions. Take care.